Hey guys, today we're going to be talking about the vocabulary that goes along with expressions. So we're mainly dealing with algebraic expressions now. So the first term we're going to talk about is a variable. A variable, as you should already know, is a letter that takes the place of an unknown value. An expression is just a math problem with numbers, operations, there should be an and here, operations, and in this case, since they're algebraic, they're going to have some variables. You don't write an equal sign. When you put the equal sign on there, we call that problem an equation. We'll be doing those later, but right now we're only doing expressions. A constant. A constant is just a plain old number. And the reason we can call numbers constants is because they never change. 5 is always 5, 10 is always 10, 20 is always 20. Numbers, the value of a number never changes. Now for variables, that is different. That's why we don't call variables a constant. Constants are things that are always the same. Coefficient is definitely a new term for you guys. And it is just a number that is being multiplied by a variable. So when you see 4n, remember a number beside a variable means to multiply. This is your coefficient, only the 4. Okay? Not the variable, and it's not 4n. It is only, the coefficient is only the number that's multiplied by a variable. Okay? Number of terms. These are the parts of an expression separated by a plus or a minus sign. So it's just like the pieces or the parts. I'll give you an example of that in a minute. Like terms, this is also very important, guys. Like terms is very, very, very important. Like terms have the same variable raised to the same power. So when we're looking at terms that have variables, they have to be the same variable to the same power. So if we had 4x and x, do these have the same variable? Yes. Are they to the same power? Yes. So these are like terms. If you had 4x and then an x squared, are these the same variable? Yes. Are they to the same power? No. So this is not like terms. And more importantly, guys, constants, which are plain old numbers, remember, constants are also like terms. Very, very important there, okay? All right. So what we're going to do now is we're going to apply the vocabulary terms to these expressions and find examples of each. All right, so it says to list the examples of each vocabulary word for each expression. All righty, so let's look at the first one. We have 12m plus 2 plus 18r plus 3 plus r squared plus 23. Whew, that is a mouthful. Okay, we want to find any variables that are in that problem. So if you forgot what a variable was, you're going to come up here, and it's the letters that take the place of a number. So the letters in here would be M, R, well, here's another M, so we don't need another M, and then this is a R squared. It is still, the variable itself, the letter is still R, so we're only going to write M and R. We need the constants that may be in our expression. So constants are just a number. Plain numbers. Is this a plain number? Nope. Is this a plain number? Yes, 2 is a constant. It's a plain number. Is this a plain number? Nope. Plain number? Nope. Plain number? No. And plain number? No. It is, you're right. I was just checking on you because we'd said no so many times. I was just seeing if you caught me. So this is a constant. We only have 2 plain numbers in our problem, 2 and 23. All right. Coefficients. These are a little more difficult because you haven't used this term before. So we're looking for a number that's being multiplied by a variable. Okay? And I've stressed to everyone, when we're writing a number times a variable, the most common way to do that is writing them side by side with nothing between. So that will help you. If you've been following that, it will help you because this shows multiplication. Now the coefficient is only the number, so the coefficient is just 12. That one doesn't have a variable. Are we multiplying a number and a variable? And what is the number? 18. You only want the number for the coefficient. Are we multiplying a number by a variable? Yes, that would be the 3. And this one, a lot of people say we're not multiplying a number by a variable, but this is tricky, tricky, tricky. If you have an r squared, you technically have one of those. You have 1r squared. So we could write that imaginary 1. Most people will not write it when they're putting it in a problem, but you need to know it's there. If you have 1 times r squared, that just means you have r squared. Okay, so this one is tricky. There is a 1. Even it's the imaginary 1. I'm going to put on here, that one is tricky. Okay? All right. Number of terms. The parts of an expression separated by a plus or a minus. Well, here's a plus, and so here's 1 part, 2 parts, 3 parts, 4 parts, 5, 6 parts. So there's 6 terms. Do not count the pluses or the minuses. It is the pieces in between. See, if you counted 1, 2, 3, 4, 5 pluses, those are not the parts. Those are just the operational signs. It's the pieces in between. That's the most common mistake. All right, like terms. This is where it gets really kind of difficult because until you've practiced this, it's really not easy. Like terms have the same variable raised to the same power, or they're plain old constants. Okay, so if we look up here, I like to start with constants because those are nice. Plain numbers, do I have any of those? Yes and yes. So that would be 2 and, that's the and symbol, 23 are like terms. All right, now let's move on to the terms that have variables. We need to see the variables that are the same letter raised to the same power, which means you have the same exponent. Okay, so these are m's, not m's, not m's. These are m's, and they both are plain m's, so that means they are to the same power. So you're going to put a comma, 12m and 3m. Let's keep looking. Do we have any more plain m's? Nope, no more plain m's. Okay, the next variable we have, because we already did our constants, the next variable we have is r. Not an r, not an r. Oh, yes, it is an r, but it's an r squared. And the definition says it has to be the same power as well as the same variable. Okay, so these are not going to be like terms because they're not to the same power. That's not an r, and that's not an r. So we have 2 pairs of like terms in this problem. All right, we're going to do one more together, and then we'll have you practice on your own. All right, here we go. What are the variables in here? We have 2 variables, c and r. Do we have any constants? Constants are just a plain old number. Do we have any plain old numbers? Ooh, people don't think this is a plain number. But this really means to do 8 times 8, which is what? 64. So that's a plain number. The constant is 8 squared. Don't let that one trick you, okay? Just because there's an exponent doesn't mean it's not going to give you a plain number. Coefficients. That is a number multiplied by a variable. So we have a 6 times the c, a 9 times the c squared, an 8 times the r, and then we have another 6 times c squared. But since these are the same, I'm not going to list it twice. Number of terms are your pieces between the pluses and the minuses. 1, 2, 3, 4, 5. And now like terms. We have a c, not a c, not a c, not a c, not a c, because these are c squares. They have to be same variable and same power. So this one and these two are not. This one and this one is not. But what about this 9c squared? That has a c squared, so those are like terms. So 9c squared and 6c squared. Okay, we have an r, no other r's, and we have one constant, so that is the only pair of like terms that we have. All right, I want you to practice the last 3 on your own. Pause the video, come back when you're done, see how you do. Welcome back. So you need to check the last 3 questions. Pause the video to see if you made some mistakes so you can fix it. But just remember, make sure you pay attention to your vocab. Like terms are the same variable to the same power. Constants are like terms. Constants are plain numbers. Variables are letters that take the place of unknown numbers. Coefficients are numbers multiplied by a variable. And the parts, the number of terms in an expression are the pieces or the parts separated by plus or minus. The more you practice these, the better you'll learn it. Good luck.